to talk about the polygon angle sum. Polygon interior angle sum. We can work out the interior angle sum of any polygon by splitting it into triangles. Remember that the three angles in a triangle are going to add to 180 degrees. So if we have a triangle, its interior angles, the three angles inside, add up to 180 degrees. Now, if we had a four-sided figure, that's called a quadrilateral. And if we split it into triangles, so we cut it in half, each triangle is worth 180 degrees. There are two triangles in a quadrilateral, so that would be 2 times 180, meaning any quadrilateral has a total interior angle sum of 360 degrees. If we keep this going with a pentagon, using kind of the same point to cut the angle or draw the diagonals, we can create 3 triangles when we have a 5-sided shape in which each triangle is worth 180 degrees. So a pentagon is going to have 3 times 180, or 540 degrees. So we can, if a polygon has n sides, there will always be n minus 2 triangles inside. A 4-sided shape has 2 triangles. A 5-sided shape had 3 triangles. So we take the number of sides minus 2, and we can times that by 180, which is my big theorem for our polygon interior angle sum. This is the formula you will be using a lot moving forward. Some common names of polygons, right? Triangle, quadrilateral, pentagon, 3, 4, 5-sided. Well, as we get bigger, 6-sided, 7-sided, 8-sided, 9-sided, 10-sided, they have certain names. And these are common ones that you should most likely be able to remember. If a shape has more than 10 sides, you can call it an n-gon. For example, if we had a 15-sided polygon, you can just call it a 15-gon. But it does have a name. So if you Googled 15-gon, I'm going to pause it, you can try, it'll tell you that it is a pentadecagon, which makes sense. Pentagon 5, decagon 10. Put the words together, we get 15. Pentadecagon. But you don't have to know anything beyond 10-sided. A regular polygon. Remember, a regular polygon means that all of the sides and all of the angles are equal. So when we see these little angle arcs, that indicates that each angle is equal. When we see the tick marks, that indicates that all the sides are equal. Our exterior angle sum, it's 360 degrees for all polygons. Interior angles are inside the shape. Exterior angles are outside the shape. And a little exercise I'm going to show you is if I were to take this piece, I'm going to pull it over here, and then I take this piece, and then I'm taking this one, and I'm going around this shape. And you'll notice that as I piece together all 6 exterior angles, it forms a circle. No matter how many sides, all polygons, the exterior angles are 360 degrees. So the polygon below is a regular polygon. Remember, a regular polygon means equal sides and equal angles. This fact, equal angles, is what we're going to be using the most. If we need to name the polygon, we need to count the sides. So as I go around this polygon and count the sides, there are a total of 9 sides. So a 9-sided polygon, if you need to go back to the video, 9-sided was called a nonagon. Now we need to find the interior angle sum. We talked about this formula. It's the number of sides minus 2 times 180. Because if we pick this point and we started drawing diagonals to make a triangle, we could make 7 triangles. Or we take 9 minus 2, gives us our 7. 7 times 180 tells us that the interior angle sum of a nonagon is 1,260 degrees. If we need to find the measure of each interior angle, recall that each angle in a regular polygon is equal. That means all 9 angles have to be the same measurement. So we need to take our 1,260 degrees and divide it into 9 equal parts. That's going to leave us with 140 degrees. So every angle in this nonagon is 140 degrees, every interior angle. Next, it asks us to find the measure of each exterior angle. These are our exterior angles. They form a straight line with our shape, and it's outside the polygon. Remember, all exterior angles in any polygon, no matter how, if it's 5-sided, 6-sided, 9-sided, the sum of the exterior angles will always be 360 degrees. If we count up the angles, we have 9 angles. So if each one is equal, we need to divide our 360 by 9, leaving us with 40 degrees. So each angle, each exterior angle is 40 degrees, which makes sense. If our interior angle is 140, see how this forms a straight line? That's our supplementary angles. So we go all the way to this side. Well, this is 180. So if this is 140, this missing side would have to be 40 degrees.